to move quicker. So number 52, I already wrote down the calculations here. Pause it, read it. So it says 1 liter, right? This is my volume 1 and my volume 2. It's not changing. 0.9 atmospheres pressure, that's my P1. The temperature is 22 degrees Celsius. Remember, we have to change Celsius to Kelvin. So I added 273. This is my temperature 1. How much more pressure? This is pressure 2 is SN4. If the gas exit, if the temperature is raised or increased to 44.6 Celsius. So this is my T2 when I add 273. So you have P, you have V, you have T. So you have to use this formula here that you're going to have in your exam. So all I did is I substitute, I was 0.91, 295 P2 times 1 divided by 317.6. I divide by 295 to get P2 by itself. So when I put in the calculator, you're going to get easier numbers in the exam. 0.97. Now I have two choices. Is my answer Celsius or ATM? So if it's asking for pressure, P2, then we know it's ATM, or atmospheres. Number 53, it's asking what is the pressure difference. So the pressure difference, all I have to do is take the first reading, 25, subtract it by 16. That's going to give me 9. Which pressure measurement is used in pressure cookers and car tires? When you're measuring your car tires, right, you use the instrument, and this reading over here gives you the gauge pressure. Gauge pressure. So, number 55, the pressure inside a tire is measured at 36 psi. So this is my gauge pressure. What is the gauge pressure if the atmospheric pressure is 14.7 pounds per square inch? I think the mistake here is they wanted to ask for absolute pressure. So my gauge pressure is 36. My absolute pressure, I want to know what it is, and my atmospheric pressure is 14.7 psi. So my formula for absolute pressure, I'll write absolute pressure equals gauge pressure plus atmospheric pressure. So my gauge pressure is 36. My atmospheric pressure is 14.7. I add them together. 36 plus 14.7 is 50.7. Actually, I'll do it this way so you guys see. So 0 plus 7 is 7. 6 plus 4 is 10. Put a 1 over here. 1 plus 3 plus 1 is 50. Bring down the decimal. 50.7 pounds per square inch. Which pressure measurement is used in scientific experiments and calculations? Absolute pressure. When you're dealing with scientific experiments, absolute pressure, absolute temperature, this is your keyword. A pressure gauge indicates a reading of 25 kilopascals. What is the absolute pressure if the atmospheric pressure is 1 or 1.3 kilopascals? So my absolute equals my gauge pressure plus atmospheric pressure. So my gauge pressure is 25. My atmospheric pressure is 101.3. I add that together. I'm going to get 126.3. A body of mass is 120 kilograms, so M, and the density is 600 kilograms per cubic meter. Floats in water. What will be the volume? So there's D equals M over V. You'll have this formula in your exam, or if you want, you could use the triangle. M, D, V. So if I want to know what my volume is, cancel this out. V equals M over V. My mass is 120. Density is 600. There's a lot of ways I could do this, but we'll do it like this. 120 over 600, if I simplify it, the zeros cancel each other out. 12 over 60, I can divide it by 12. It's going to be 1 over 5. 1 over 5 equals 0.2. 0.2, so look at kilograms, and I have my kilograms up here. I need my meters cubed. 0.2 meters cubed. Which of the three blocks has the greatest density? So the greatest density is A, which is a solid. It's more dense. The particles are close together. They're packed. A block has a mass of 20 grams and a volume of 40 cubic centimeters. What is the density? So density equals mass over volume, 20 over 40, which is half, 0.5 grams per cubic centimeters. Which of the following substances has the highest density? So which one has the highest number or the biggest number? Aluminium. We should know that because aluminium is a metal. It's very dense. Number 62, the density of a substance, so D equals 800 kilograms per cubic meters. If the density of water is 1,000 kilograms per cubic meters, what is the relative density? So when I take the relative density, my RD is just the density of the object of the substance, 800 over the density of the water. This is going to be 0.8. Alright, cancel this out, cancel this, cancel this, cancel this. 8 over 10 equals 0.8. What happens to liquid pressure as you go deeper underwater? If I go deep into the water, the pressure increases. Calculate the pressure exerted by the water on the fish. So liquid pressure equals density times gravity times height. Instead of this, I'll use a D. So my density of water is 1,000. Gravity, or the G here, we're going to say is 10. It's 9.8, 9.81, but we'll use 10. And my height is my, over here, the meters, 5 meters. So 1,000 times 10 is 10,000 times 5 is 50,000. So 5, I have 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Or, say 5 times 10 to the 4th power. And 65, this is the last one. The pressure at the bottom of a water tank is 5,000 newtons per square meters. If the density, it's actually pressure, the density of water is 1,000, and the acceleration due to gravity is approximately 9.8 g. What is the height of the water column? So, pressure equals P, or rho, sorry, dgh. My P is 5,000. My density is 1,000. My gravity, we'll just say 10. Get an approximate answer. My H, we don't know. So, 1,000 times 10 is 10,000. I'm going to divide by 1,000 now. So cancel, 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 cancel. I did something wrong. Sorry, I'm interested. Oh, sorry. Okay. 10,000. Right? And divide by 10,000. Divide by 10,000. So just cancels each other out. For every 0, I'm going to cross out 1 0. So 5 over 10 is approximately my h, or my height. 5 over 10 is 0.5. So is it going to be 0.51 kilometers or meters? I'm going to look. It'll be meters because the h, the height is always in meters. Gravity is newtons per square meters, and the density will be kilograms per meter or cubic meters. So my answer is 0.51 meters.